right, so Andrew's just mentioned a quick question. The question is, when you create an account with Docker Hub, does it automatically have a Hello World? Good question. So the Hello World container is something that is provided on Docker Hub. So again, you can think of Docker Hub like a big repository for containers, and Hello World is just an example one. So you don't actually need a Docker Hub account to pull that Hello World container. That's a public image, so you can do that without creating an account at all. The only reason that we created an account is because we needed it for that Play with Docker setting, or Play with Docker tool. So to answer your question, I guess yes, it does automatically have that Hello World container, but it's not necessary to create an account to see it. All right, and it's 1:26, so I think we're going to go ahead and jump into the next lab here. If you haven't quite gotten everything done, don't sweat it. The workbook is yours to keep, and you can follow along with it at your own speed. And of course, any questions or anything like that, you can ping me on Twitter or ping Andrew, and he can pass them along, or we'll definitely get those answered for you one way or another. So we're going to look at Lab 2 now. We're going to run some basic Docker commands. So Docker borrows a lot from Linux commands. So if you know a little bit of Linux, a lot of the stuff we're doing today is going to look real familiar. You can use the Docker PS command to list running or stopped containers. This is really useful for troubleshooting. So if you run a container and it stops all of a sudden, you can use Docker PS to see that container is stopped and to start troubleshooting why that happened. Docker pull is kind of like git pull. It'll make sure that your local copy of a Docker container is the latest version. When we ran the Hello World container, it automatically did a Docker pull because it checked to see if the container existed locally, and when it didn't, it pulled it down. So Docker pull is just if you want to do that manually, or if you're working as part of a team and someone pushes a new version that you don't necessarily want to run, but you still want to have the local copy on the latest version, you can do Docker pull to get that. Docker run, as we saw, will run the Docker container in most cases. So some containers require you to pass in parameters in order for them to know what they're supposed to do. So if you run a container and nothing happens, that might be just because it's expecting you to provide some extra input. But Docker run is what you use to run the container. When you're using Docker run, there's a flag you can pass called -it. This will run the container interactively. That's the I part. And as a teletype terminal, that's the T part. A teletype terminal is a really old way of interacting with Linux systems, but the terminology kind of stuck around through the years. So that's the history behind that one. And finally, Docker RM will remove the locally downloaded copy of a container on your system. This can be useful in cases where you're pushing containers to the repo and you're maybe not tagging them properly, or you're reusing a tag. You can remove your local copy and then pull a fresh one. And we'll take a look here and see what that looks like. So I'm just gonna drag my Docker Playground instance back over. And just gotta find my workbook here. All right, so let's start by running Docker PS. So Docker PS is short for processes, and when we run it, we don't see anything listed here. That's a little interesting because we ran Hello World, so we should have something here because that process ran and then terminated. So if we pass the -a for all, that will include stopped processes. And we can see the container ID here, the image that it was running, Hello World, the command that it was running, so this is the command inside the container, which is in this case is just a script called hello. When it was created, about 9 minutes ago, so that was when we pulled it down. What the status was, exited 0. That means it did what it was supposed to do, and it exited without errors. Ports, these are any ports that are open on the system. We'll talk about those in a little bit here. And the name. We didn't tell it to run with a specific name, so it just generated one from a list. In this case, it was Angry Dubney. So that was pretty cool. Let's pull down a new container, something a little more interesting. So we're going to do Docker pull busybox : latest, and it's going to pull the latest from the library busybox repo. Pull is complete. Downloaded a newer version, and now we have this image locally. We can see it by running Docker images, These are the images that exist locally on our system. So we've got BusyBox here and Hello World here. And again, we didn't necessarily have to do a docker pull command here. This is just to show you what that command is. If we just tried to run this, it would see that doesn't exist locally and just pull it down for us. But this is just so that we can see what that pull process looks like. So now let's run it. And we're going to do that docker by running docker run BusyBox. And it didn't do a whole lot of anything, did it? So here's where we typed in our command, we pressed enter, and it just spit us back out to our prompt without doing anything. So that's a little weird. The reason that it did this is because the BusyBox image expects us to tell it what to do. If we don't tell it what to do, it's just going to start up, see that there's no input, and then shut down. So let's, I happen to know there's a command that exists in here called echo. So we're gonna echo with BusyBox. And just so you see what I did there, if you press the up arrow on your keyboard, it'll jump to the previously run command. So we can save a little bit of time by doing that. So docker run BusyBox, echo, double quote, hello world. We close the double quote, we press enter. Docker run BusyBox hello world. You can see right here it spit out what we supplied inside the quotes. So what's happened here is we started up a BusyBox container. We told it to run this echo hello world command. It ran the echo hello world command, printed it out to what's called standard out, which is the standard output that we see on this terminal, and then it terminated. So that's pretty cool. But let's run the container interactively now, so we can poke around at stuff inside of it. So we're going to do docker run BusyBox. No, sorry, actually, we're going to do, let's break out of that. We'll go docker run -it, which is what we have to pass to run the container interactively. BusyBox. And we're going to run the sh command. Sh is short for shell, and it's basically just a shell is the way that you interact with a Linux system. So this whole window right here is an example of a shell, but we're going to run a different shell now inside the BusyBox container. So watch our prompt here. So see right here, our prompt is just this $sign. We're going to press enter, and our prompt has changed to this slash and then the pound sign. So if we, what we're going to do now is take a look around. So this is the actual inside of the container. So we can type ls here to list the current directory. We can see a bunch of folders and stuff. These did not exist outside of our container. So if we exit and type ls, we're in an empty directory here. So when we run this command, we're running a container interactively. We're in the slash or the root directory, and we can see the entire file system inside this container. One of the really neat things you can do with containers is you can use them for testing stuff. So as you saw, we ran ls, and we can see all of these directories. But now we're going to break this container. So we're going to use the rm, which is short for remove, and you can use this for removing files or folders, /bin/ls. Bin is where the binaries live. A binary is just another way of saying a program, and ls is the program that we're removing. When we do this ls up here, we're listing the directory. So we're going to remove this, and then we're going to try to run ls again. It's going to spit out an error because we've just deleted that binary. So now we're going to exit the container, and we're going to rerun the container, and we're going to try to ls, and it's back to normal. The reason it's back to normal is because that container existed to run our shell, and when we typed exit, we terminated the shell, and then that container is just gone. Well, it's not gone. That's not totally right. It stopped. But when we run the docker run it BusyBox sh command a second time, it starts a new version of that container from the image we pulled down from Docker Hub, and that image has the ls command in it, which is pretty darn cool. So no matter what we do inside a Docker container, with some exceptions, like if you've done something silly like mounted a file system inside a container and then deleted every single file, you're going to have a bad time there. But in this case, we broke our container, we stopped it, we started it, and now we have a new container that's working exactly the way it should be. So we're going to go ahead and exit this container. And now let's take a look at Docker ps-a again. And whoa, look at all these. So every time you run a container, it still exists on your system in some shape. And in this case, these containers are taking up space on our system. So we're going to go ahead and delete them. And you can use docker rm, and let's pick Let's go with Brave Newton, and this goes by name at the end here. And what I did there too, just so you guys can see, is the Linux shell has an autocomplete feature. So if you start typing a thing, so in this case we'll type brav and press tab, it'll autocomplete the rest of the container name, which is really cool. So we're going to do docker rm Brave Newton, and we'll do ps-a again, and we can see Brave Mr. Newton is gone from the list. So that's cool, but we don't want to do it for every single container. So we're going to do another command called docker system prune, and what this will do is it will remove all stopped containers, all of the networks that may be created that aren't used by at least one container. This doesn't include the networks on your host system or anything like that, so it's non-destructive in that way, so don't worry about that. Dangling images, that is to say images that aren't attached to any of our other images, and dangling build cache. I don't actually remember what that one is, but doesn't really matter for our purposes here. So we're just going to say yes to this, and it's deleted a whole bunch of containers. I mentioned they were taking up space. They were not taking up a whole lot of space, so a whopping 38 bytes was recovered by doing that docker system prune. And if we do another ps-a, all is well in the world again. We're not eating up any more space on our system, which is pretty cool. So that's all I wanted to show you about that. We're going to take another 5 here, and please feel free to try out lab number 2, and we'll touch base again in just another 5 minutes. Okay, it's about a minute early, but I'm looking at the time here, and I think we're going to jump back in right about now. I have a real tendency of getting overexcited about things and explaining outside of my notes, which is sort of slowing things down a little bit. So I'm going to jump into the next lab here and try to go through it a little bit quicker. But again, any questions, just holler them out. So, it's really cool to run all these pre-built containers, but let's build our own next. So Docker uses what's called a Docker file, with a capital D, that's important, to define your Docker containers configuration. Docker containers are made up of what are called layers, and each line in a Docker container is a layer inside the container that each line inside a Docker file is a layer inside of the container that you're defining. It's really important to keep that in mind when you're making changes to a Docker file, because all of the layers, whenever you make a change in a Docker file, all of the all of the lines or layers that come after it have to be rebuilt as well. This isn't a big deal usually, but if you've got like a Docker file that's 1,000 lines or like a crazy big Docker image, it might take you a really long time to rebuild it. So you got to be careful about that. Once you build your Docker file locally, it's really important to remember to push it to Docker Hub. In case you're using Docker Hub, there are lots of other repos and stuff out there that you might be using as well. But you have to remember, it's just like committing your code in Git. If you don't push it and get it into that master branch, it doesn't exist. So that basically just make sure that it's there and backed up safely. So I'm gonna get the screen back up here. So I mentioned that this platform had a couple of quirks, and one of them is called Vim. So Vim is a text editor that is and it's the only text editor that exists in these play with Docker environments. Vim is notoriously tricky to use, to the point where being able to quit Vim is almost a meme. So if you get trapped in the editor, the only thing you need to know is escape : Q ! That will quit without changes. So if if you're following along and things look really funky, escape : Q ! Will quit without changes, and then you can try again. What I recommend to people if they're having trouble is type it up in Notepad or whatever local text editor on your machine, and then you can just copy and paste it in, which is a whole heck of a lot easier. So we're going to start in the current directory here, which is empty, by typing vim docker file with a capital D. And so with Vim, you're not actually in a mode where you can type right off the bat. You have to press the I key on your keyboard to enter insert mode. You can see right down here at the bottom it says insert, and this treats it like a normal text editor. So you can type whatever you want, and it'll show up in the thing. So we're going to go ahead and type in our first Docker container, or our first Docker file line, which is from, all in caps, and we're going to go from busy box : latest. The colon latest is the tag. So this means we're pulling down the very latest version of BusyBox. If you're building like an application, you're generally going to want to use a specific tag, which corresponds to like a version of the application, so that like you don't next time you run the application, it doesn't pull down a newer version and cause some weird issues with your app. But for now, for what we're doing, latest is totally fine. We're going to add a line called maintainer. And this is what's called metadata, and this is just letting people who look at this container know who made it. And you're going to type in, your name, or you can make up a name, someone, and then just the email, someone@somewhere.com. I didn't spell that right, but that is a-okay. And the next line is the command. So this is what the container is actually going to do. We're going to define this by typing cmd. And the syntax is a little funky here, but we're going to do a square bracket, a double quote, and the command we're going to run is date. Then we're going to end the double quote, end the square bracket, and to quit Vim, we press, it's almost the same as the emergency quit thing that I talked about. You press escape on your keyboard. You can see that insert vanishes, and you type colon, so that's the shift and the semicolon key, WQ. W for write and Q for quit, and press enter. If we type ls here, we can see our Docker file exists, and now we are going to build it. Having a Docker file is really cool, but it's not actually a container until we execute this docker build command to translate what we've written into a container. You can think of this kind of like compiling your code. So we're going to run docker build -t, and we're going to call this example :v1. So the -t switch is short for tag. So this is, trying to remember if I explained this or not already, I can't recall, but basically the tag is like how you identify the repository that your Docker container is in and the version it's in. So in this case, docker build -t example is the name of our Docker container, and v1 is the tag. We're going to go ahead and press enter. Oops. Docker build -t. Oh, I forgot something very important. So right after the v1, you put a space and a period. So period is a shorthand Linux notation for the current directory. So when we run docker build, it wants us to specify the location of the Docker file. And we can sort of cheat by just doing period, which says look in the current directory for a Docker file. But we can also type it out longhand, Docker file. I think this will work. Let's find out. Oh, yeah, it has to be a directory. So, yeah, that's why we use the period. So docker build -t example v1 period. Press enter, and it's going to spit out a bunch of stuff here. So remember I said that every line in a Docker file is a layer, and that's what it's doing here. So you can see step 1 out of 3 from BusyBox latest, and it's compiled that into a layer ID for us. Step 2 out of 3, maintainer someone at somewhere.com. It's built that into a layer for us as well, and it removes the intermediate container. I don't remember what that means, but we'll gloss over it. And step 3, the command, is also a layer. And it's successfully built. We have an image here tagged example :v1. So let's run it. Let's first go docker images, and we can see a repository called example, a tag called v1, and some metadata and some data about it, the image ID, when it was created, and the size. This just tells us that the container exists, but the important distinction here is that it exists on our local system. So we're going to run it. Docker run example :v1, and we'll press enter. And just like that, it spit out the date and time, which is what the date command does. So that's pretty cool. We've built our very first Docker container that we can use to tell us what the day is. It's not super useful, but it's still pretty neat because we built it ourselves. The next thing we need to do is log in to our Docker Hub account so that we can take this and push it somewhere where our friends can get at it. So we're just going to type in Docker here, get my password onto the clipboard. Oops. Sure. Don't know why I did that, but that's okay. I'm just going to run it one more time. Docker, copy the password. And in order to get the this container logged into our account, we run the docker login command. We enter our username. Very important distinction here. Your username is not your email address. It's your Docker ID. So in my case, it's dbriggs555, I think. And the password, we can just right-click and paste. And what we care about here is this login succeeded thing. Take careful note of the warning. Your password's stored unencrypted. This is the main reason why we didn't want to use our regular password. So make sure you use something special there. And before we can do this, we have to go to our list of repositories. So in a new browser tab, go to hub.docker.com, click on repositories. And if I was a little more clever, I would have remembered to delete this when I was getting ready for today, but I didn't. So you know what? We're just going to do a new one called example 2. And description, you can enter any old nonsense. Visibility, you want to make it public probably for the sake of this class, but you can do your free account gives you one free private repo too, so you can do that as well. Important thing to remember is that you won't be able to pull it without logging in if you make it in a private repo, so just be careful of that. And we don't care about any of the build settings here for now. So go ahead and click create. And you can see here it gives us an explanation of how to push our stuff to it. So what we're going to do now is jump back to Docker Playground, and before we can push the image we made, we have to build it one more time. And the reason we have to build it one more time is because the name of the tag is how the Docker build command and the Docker push command know where to push the file. So we're going to, actually I'll type it from scratch, Docker build -t dbriggs555 /example2 v1, and the all-important period at the end to make sure it knows where to build it. We press enter, and it's going to do the exact same thing it just did. It's going to go through and build all of this stuff. And the next thing we have to do is push it. So that this is kind of like we built our local copy, and now we have to commit it to the repository. And we're going to do that almost the same way. Docker push to push it to the repository. dbriggs555 /example2 v1. And because the image is built on our system and it's in the local images cache, we don't need that period at the end. We've already built it. The period at the end is just for building. And we press enter. This push refers to this repo. That's all fine and dandy. It didn't spit out any errors. That's pretty much what we want to see. And we'll jump back to Docker Hub here, refresh the page, and we can see a v1 tag here. Very cool. So now let's go back. We'll go Docker system prune, yes. Deleted a whole bunch of images. Docker images. We can see, that's okay. Yeah, doesn't super matter. So if this image didn't exist on our system, when we tried to run it, it would pull it down. I don't know why the delete command didn't work, but it's not super important right now, so I'm going to gloss over it. What is important is running our image we just pushed. So we'll do Docker run, and when you're running the image, even though it's in Docker Hub, we still have to specify our username. So we're going to do Docker run dbriggs555 /example2 v1, and you can do :v1 or you can do latest. Latest is a special tag that exists just by virtue of being the latest version in the repository. But as I mentioned, it's best practice to use a specific tag, so we're going to do that. So we'll do Docker run blah, and just like that, it spits out the date. Pretty cool. So yeah, that's about all I wanted to say about that. We're going to get this probably closer to 3 minutes here, which is unfortunate because it's a little bit of a longer lesson, but I don't want to go over time. And we'll jump into the next 2 labs right after that. So yeah, holler out any questions if you have them, and we'll see you again in just a few minutes.